Welcome back, ladies and gentlemen. Today we're going to take a look at GCF and LCM and describe the difference in the two of them and kind of rock and roll from there. So GCF stands for the greatest common factor and least common multiple stands for LCM. So the first thing we're going to take a look at is, can we describe the difference between a monomial and a polynomial? So a monomial is when it talks about one single term, okay, while a polynomial stands for multiple terms. Okay, so if you're talking about like one term, you could say something like 2x. Okay, just that's 2x. That's it. Boom. All right. Polynomial will be something along the lines of like 2x squared plus 3x plus 2, which is quadratic, so on and so forth. Okay. We're going to talk today about factors of a number, and that's the numbers that multiply together to give you the original number. All right. A prime factorization is when we find all the prime numbers that can go into the original number. Please try to remember that a prime number is a positive number greater than 1, which only has the factors 1 itself. So for example, 3 would be a prime number because 3 can only be divided by 3 and also 1. Okay. So when it says factor the following monomials completely, okay, we want to try and factor these so that you break them down to prime numbers. All right, and also break up your variables. So for 6, that can be broken down to 2 times 3. All right, and then you also have x squared, which is just x and x. Okay, so the fully factored form there is 2 times 3 times x times x. You're good. Okay. Now for 18, you can break that down to 2 and 9. All right, but then 9 can be broken down to 3 times 3. Okay, so we have 2 times 3 times x times y times y times y. Okay, so we're all good there. 24, I always just divide by 2, so you get 2 and 12, and then you can get 2 and 6, and then this would be 2 and 3. I'm writing really small, I know they're small boxes. So I have 2 times 2 times 2 times 3 times x times x times y times y. All right, and you can see why it's so beneficial to write it as x squared, because it's way easier than running out 2 times all the time. Finally, 10, we can do 2 and 5. Okay, so that's 2 times 5. Then I've got 1x, I've got 2 y's, and I've got 3 z's. Okay, cool. Alright, so we are going to get into the greatest common factor, or also the greatest common divisor, sometimes referred to as, okay? So there's lots of methods for doing this. One of them is to, if you're trying to find them, you can go ahead and you break everything down like we just did up here with your 2 terms. So they're giving you examples, 6x cubed and 30x to the 4th, 3 times 2 times x times x times x, 2 times 3 times 5 times x times x times x times x. And what you do is you circle the common terms. So like there's 2 and 3 in both of these. Sweet. So that's why that's in common there. And then I have 3 common x's over here with the 3 common x's over there. So if you multiply everything out, 2 times 3 gives me 6. X times x times x equals 6x cubed. Okay. So I'm going to show you guys a little bit of a shortcut here, because sometimes it is tough to remember all these things. But there is a way to do this in a calculator. Now, the thing with the calculator is, all right, that you can only do it with the numbers. So when it says 8 and 10, if you want to find the GCF between 8 and 10, you may hit the math button, okay? And if you go to the right, that underlines number, if I scroll down in this calculator, number 9 says GCD. That's your greatest common divisor, okay? So what you can do is actually hit enter, okay? Now I want to put in 8 and 10, and I want a comma between them. 8, comma, 10. Notice that I am not putting the letters in there. I'm only putting the numbers. And if I hit that, it does it for me. This is tremendously helpful, okay? So the greatest common divisor between 8 and 10 is 2. Now, here's the trick for variables. You want to go low when you're trying to find the GCF between variables. Now, what do I mean by that? X to the third, x to the first. What's the lower one? X to the third or x to the first? Well, the lower one would be x. Because think about what we did up there. You went x times x times x, and you went x. What's common? Well, the 1's common in both of them. Okay. Between y squared and y to the third, which one's lower? Well, that would be y squared. Done. Okay, so nice and easy. All right. Now, the only trick with this calculator is that you can't do 3 numbers at once. So if you want, I can come over here and do my GCD again. Okay, so I'm going to do 728, 7 comma 28. It gives me my GCD as 7. Well, then I want to do my answer here. 7 was 14. Okay, 7 comma 14. Okay, so 7 is my greatest common denominator, greatest common factor. Okay, for these 3. And then x to the third, x to the fourth. The lowest one is x. Cool. All right. One more time over here. Between 16. Notice again, I'm going to keep repeating myself. I'm just doing the numbers here. GCD, 16. Make sure you remember that comma. 84. My answer is 4. Let's go again. Math. GCD, take your answer. 4, comma, 36. Okay, so my GCD between 16, 84, and 36 is 4. Now let's look at our variables. X to the second, x to the first, x to the second. What's the lowest one? X to the first, y squared, y squared. The lowest one is y. All good. Okay, so GCF, we go low. All right. Pardon me. On my next page, okay, we're going to talk about LCM. LCM, you go high. All right. So I'm going to show you guys this one here. I'm going to kind of jump right to the calculator here. If you're trying to find the LCM between terms, okay, I know we have some extra stuff up here if you'd like to check it out, but I'm going back to math. This time I'm not going to number 9, but if you go to number 8, it straight up tells you LCM. So 4, comma 6. This is called your least common multiple. It's what number can they both multiply to get to? 12. So LCM, we go high, which I know can be a little confusing because least, you would think the opposite, but you're actually going high, okay? Between 5 and 6, sorry, I'm trying to find a good spot. You can see this. Math, LCM, 5, comma 6. There's 30. Okay, 3, 8, and 12. Okay, I'm scrolling down number 8. 3, comma 8. The LCM is 24. Do it again. I'm doing a 24, comma 12. So 24 is my LCM. Cool. Now, for variables, go high. GCF we went low, LCM we're going to go high. Between y to the third and y to the seventh, the higher one would be y to the seventh. Okay? So let's put this together now. So if I want to find the LCM between 3x squared and 10, I go math, okay, number 8, 3, comma 10. So 30 is my number. Between x squared and nothing, the higher one is x squared. Okay, that one's a little tricky. Very good. Okay, 16 and 32. Okay, math. 16, comma 32. The LCM is going to be 32. Some of you guys, oops, pardon me. Some of you guys might already know that, which is totally fine. Between x squared and x, the higher one is x squared. Between y and no y, the higher one is y. Done. Okay. All right, 18 and 24. Again, going back to my calculator. Math, number, LCM, 18, comma 24. We get 72. Okay, let's go ahead and pull out all the stops here. M squared, m to the fifth. For LCM, we go high. Which one's higher? M to the fifth. For n to the third, n squared. The higher one is n to the third. And then lastly, I have no p and p. The higher one is p. Okay, very good. All right, last two word problems. Yes, I know word problems are scary, but let's look for keywords. A math teacher and a science teacher combine their first period classes for a group activity. The math class has 24 students and the science class has 16 students. The students need to divide themselves into groups of the same size. Each group must have the same number of math students. Find the greatest number of groups possible. How many students from each class are in each group? Okay, well, if you're looking at 24 and 16, I'm trying to go low. I'm trying to make them into smaller groups, okay? So find the greatest number, GCD, okay? GCF or GCD. So I want to find the greatest common divisor of 24 and 16. Okay, so what I can then do is I go GCD, math, go to the right, number 9, 24, 16. So 8. Okay, so my GCD is 8. Right. So when I take a look at that, so because I have 8, I know I can divide my 24 math students into 3 groups, 3 math groups. Okay, and then I can divide my 16 science by 8 to get 2 science groups. Okay, so we're all good there. Mr. Drake bought muffins and drinks for a breakfast meeting. The muffins were sold in packages of 12, and the drinks were sold in packages of 18. What is the smallest or the least number of packages of each item that Mr. Drake could have brought to sell the same number of muffins and drinks? So, because I'm trying to get the smallest number of groups, I'm buying multiple packages. Here I'm doing LCM, okay, of 12 and 18. So if I go back to here, okay, much the same, math, 12, 18, I get 36, okay? Now, let's think this through. You want to get 36 muffins, okay? So I can do 36 divided by 12. That would give me 3 packages of muffins. All right, and then I can take my other one, okay, and do 36 divided by 18, okay, and get 2 packages of drinks. Okay, so look for keywords when you're looking at, like, smallest means least, greatest means, okay, GCF, all right? So great job as always. Keep up the good work, all right? If you have any questions, feel free to ask. And as always, keep up the good work and good luck. We're all counting on you.